Today we're proving that a quadrilateral is a parallelogram. So parallelograms do have to be quadrilaterals, but not all quadrilaterals are parallelograms. So let's remind ourselves of what a quadrilateral is, because I did have some questions about that the other day. A quadrilateral is a four-sided polygon. So everybody's writing that right there. A quadrilateral is a four-sided polygon. All right. If you still have your Chromebook open, let's go ahead and close it because we won't need that anymore for now. So let's go ahead and close your Chromebooks app. Go ahead and close your Chromebooks app. All the way. Thank you. Yours says 6 tests for parallelograms. We're going to change that to 7. Oh, that's the wrong one. I'm going to change that to 7. All right, so yesterday we learned about the properties of parallelograms, and this is a very similar list to that. It's not exactly the same, but very similar. Today we're making a list of criteria that if we see a diagram or quadrilateral marked with any of these things, we'll know that that quadrilateral is a parallelogram. Once again, very similar to the list of properties for a parallelogram, but not identical. What's the first thing we learned about this, the sides of a parallelogram? What do we know has to be true about the sides of a parallelogram? Hint, hint, it's in the name. Tyron? The opposite side, both pairs of opposite sides must be parallel. So if they mark both pairs of sides parallel, then we know that it's a parallelogram. That's number 1. Olivia, you good? What else do we learn about the sides of a parallelogram? Kamara? Right. Both pairs of opposite sides are congruent. What did we learn about the angles in a parallelogram? Let's start getting a little bit more specific. What did we learn about the angles in a parallelogram? So we learned something about the opposite angles, and we learned something about the consecutive angles of a parallelogram. Kamara, my go-to girl today. Go. Well, not all angles are congruent, right? Opposite angles are congruent. What did we learn about consecutive angles? First off, what are consecutive angles? Tyron? No, not all consecutive angles, when you add them together, equal 180. They will in a parallelogram, though, right? But what are consecutive angles? Here, 7x, this angle marks 7x, 56. Those are opposite angles. They don't share a side. Remember, consecutive angles, this angle and this angle, they're consecutive. They're on the left or right of one another. They also share a side. If they share a side, they're consecutive. Kamara? Kamara? Were you going to help me solve that problem?
I was just going to say that they were interior.
We are going to talk about alternate interior angles again. All right, so one angle is supplementary to both of its consecutive angles. So if we know that one angle, if you add it to the consecutive angle on the left, then it equals 180. If you add it to the consecutive angle on the right, and it equals 180, then we can say that that quadrilateral is a parallelogram. did we learn about the diagonals of parallelograms yesterday? What did we learn about the diagonals of parallelograms yesterday? You remember, Ethan? Do you remember what we learned about the diagonals of a parallelogram yesterday? Anaya? Very good, it does, and that is going to be one of the things. Well, we're not going to actually put that on that list, but you are going to use that. We are going to use that to prove that parallelograms, that a quadrilateral is a parallelogram. So that is true. Perfect. We definitely need to know that. That did not make our list of tests, but it actually technically is a test. We are going to use that in our assignment and in our notes today. There's one other thing we learned about our diagonals. If no one else knows, I need everybody to get your 6-1 notes out. Anaya's got hers out. She's doing her job. I need y'all all to be doing your job. If you don't know, they bisect each other. So everybody needs to have your 6-1 notes out, I guess, because nobody remembers anything except for Kamara, Anaya, and Tyron. Tyron? Yes, 6-2. Sorry, it was my bad. This is a new one. Number 6. We did not talk about this one. So this one, Jaden? Oh, that is true. So we happen to have a quadrilateral where they mark all 4 angles 90 degrees, then you'll know that that is a parallelogram. But this one, number 6, one pair of opposite sides are parallel and congruent. So knowing that one pair of opposite sides are parallel does not tell us that that quadrilateral is a parallelogram. Knowing that one pair of opposite sides are congruent does not tell us that that quadrilateral is a parallelogram. Normally, you need to know, if you look at number 1 and number 3, it says both pairs are parallel or both pairs are congruent. But if you don't know that, and you do know that one pair is parallel and congruent, then you could also say it's a parallelogram. So that was not in the list of our properties. But if we know that one side is parallel and that same side is also congruent, now we can say that that quadrilateral is a parallelogram. Does that make sense, Olivia? Does that make sense, Brandon? And lastly, alternate interior angles formed by the diagonal are congruent. So if we have alternate interior angles and they're congruent, then we know that the figure is a parallelogram. The quadrilateral is a parallelogram. All right, y'all caught up with me? Not quite. All right, I'll come back if you need some more time at the end. We should have time. So now we are going to we're going to use the properties of a parallelogram or our test for parallelogram to either solve for some missing measures or to say yes, this quadrilateral is a parallelogram, or to say no, that quadrilateral is either not a parallelogram or we don't have enough information to state it one way or the other. So we're going to start. We want to know what value for x and y would make the quadrilateral in example 1 would make this figure a parallelogram. So because they have only angle measures marked in the diagram, we're only looking at the properties or tests that we learned about that have to do with angles. So opposite angles are congruent, and one angle is supplementary to both of its consecutive angles. So we're looking at those two. Maybe. Here we go. So I know that 7x and 56 are opposite angles. So the angle that has a measure of 7x, the angle has a measure of 56. Those are opposite angles. They do not share sides. So I know if this is a parallelogram, those measures are equal. So that is our first equation. I also know that these angles are opposite angles. So if this is a parallelogram, then these have to be equal. So we can solve for y to find out what value would make these expressions equal. So we've got two equations. And we're going to solve for x and solve for y. So y'all go ahead and solve for x and solve for y. So when x is 8 and y is 30, those are the only values that we can use to plug in this these expressions to make this a parallelogram. If we use 7 and 30, this would not be a parallelogram because the opposite angles would not be would not necessarily be congruent because both pairs have to be congruent. If this were 7, then this angle would be 49, this angle would be 56. They would not be congruent, right? That's what we're doing. Does that make sense, Tommy? All right, so in example 2, all they give us are the measures of sides. So we're looking back at our list. What did we talk about? The tests we talk about sides are these two. The sides being parallel will not help us write an equation, right? But the sides, opposite sides being congruent, that could help us write an equation. So here, these are opposite sides. These are opposite sides. So I can write an equation setting these two sides equal to one another. And if I solve for y, that's the value that will actually make them the same length. So 4y minus 9 equals 2y plus 5. 3x plus 4 equals 5x minus 2. And solve for y. Solve for x. Does that make sense, Max? Do you already solve for them? You should have gotten x is 3 and y is 7. So when x is 3 and y is 7, this quadrilateral would be a parallelogram because that would make these two sides congruent and these two sides congruent. If you plug the 3 in here, you'd see that's 3 times 3 is 9 plus 4 is 13. 5 times 3 is 15, minus 2 is 13. That would make both of these 13. We plug in 7 here. 28 minus 9 is 19. 2 times 7 is 14, plus 5 is 19. We can see that these opposite sides are congruent when these variables have that measure. We'll see if we have enough time. All right. Did you guys have any questions about that second example? All right. What do we have marked on this example? And they're not angles. They're not angles. Some people thought they were marking angles here. These are not the measures of angles. If they're not the measures of angles, what do you think is marked here? Not the sides, right? The sides would be marked out here, right? Tyron? Right. So these are the diagonals. So 3x minus 11 is for this section. X plus 1 is for this section. 3y is for this section of the diagonal. Y plus 8 is for that section. So if this is a parallelogram, what do we know about the diagonals? Okay. What's that?
I said you good looking too much.
I haven't said a word to you. I literally like
I'm
to do
saying you look like a paper. You sit up on the bed.
What? Goodness. Yeah, I have not even said a word to you. Anna let you in the media center where you wanted to go to take your test. I feel like you don't have room for complaint today.
Oh no, I ain't okay.
All right. Tyron's right. These are the measures of the segments. If this is a parallelogram, we would know that this segment has to be congruent to this one, and this one has to be congruent to this one. So, this diagonal is split into two segments. Both of those segments have a measure that include a y, so it's going to be easy to set those equal to one another and solve for y. This diagonal is split into two segments that have measures using the variable x, so we could write that equation to solve for x. So, if this is a parallelogram, 3x minus 11 has to be equal to x plus 1. If this is a parallelogram, 3y also 3y has to be equal to y plus 8 also. Both of these things have to be true. So now we're going to solve for x. Did you grab your notes, Gad?
Oh yes, ma'am.
Okay, so we're on example 3. You should be following along with us. So I've got my variables on the same side, add 11 both sides, and solve for divided by 2 to get x equals 6. I'm going to get my variables on the same side here, divide both sides by 2, and y is 4. So what we're saying is when x is 6 and y is 4, these two diagonals would have bisected one another, and then they would be this would be a parallelogram. We won't do both this time, but you can see if y is 4, 3 times 4 would be 12, and 4 plus 8 would be 12. You'll see that those are congruent. And the same thing if we plugged in the 6 in each of these expressions, you'd see that they both equal 7. Does that make sense, Travis? All right, example 4 is a little bit different. They're still giving us the measure of angles. And they do give us a pair of opposite angles. Can I use these two angles to solve for y or x? You're right, I cannot, because one's an x and one's a y. We know if it's a parallelogram they're congruent, but I can't use those first anyway. So how about these angles? What kind of angles are these two angles? Tyron knows. What kind of angles are these two angles? Haley? They are consecutive interior angles. Very good. So they share a side. They're consecutive. What do we learn about consecutive angles in a parallelogram? Brandon, what did we learn about consecutive angles in a parallelogram? Well, look at your notes from yesterday then. Consecutive angles are what? Sorry? Look for the word consecutive in your list of properties from yesterday's notes. Say it again. Please make sure you have the right notes out. Sorry? They are supplementary. What's it mean when angles are supplementary? Because that's not what your notes say. Let's make sure you know where to find it in your notes. What's it say right here? Equals, you didn't finish writing it. That should say 180 right there. So that's why we needed to check the notes. That should say 1 equals 180. Which does mean they're supplementary, right? The supplementary is right, but in our notes yesterday, we just said that consecutive angles are equal to 180. That means the sum of those two angles is 180. So now we know that 5y plus 17y plus 48 has to be equal to 180. So now I can solve for y here because I have two expressions with the same variable. So let's write that equation. Consecutive angles are equal to 180. That means this one plus this one equals 180. I can combine my like terms. 22y plus 48. Subtract 48 from both sides. Divide both sides by 22. Now I know that y is equal to 6 if these are supplementary. Now once I know that y is equal to 6, now I can go back and set these angles equal to one another because I can replace the y with 6, right? So now I know 4 times x equals 5 times 6, or 4x equals 30. If I divide both sides by 4, x equals 7.5. Any questions on example 4? Does that make sense, Jaden? All right. I do want you to highlight or put a star by this. You do not have to prove all of those tests we just gave. You only need one of them. You only need one of them. You do not have to have all 7. Right? So for any of these tests, if I can prove that both sides are parallel, if they marked on both sides are parallel, I don't have to look any farther. I can say yes, it is a parallelogram. If they mark both sides congruent, opposite sides congruent, I can say yes, it is a parallelogram. If they have a mark that the diagonals bisect each other, I can say yes, they are a parallelogram. I do not have to have all of these marked on the diagram. Now, once they have both sides marked parallel and I say yes, it's a parallelogram, then I should understand that all of these things are true whether they're marked or not. The next set of problems is, can we prove that each quadrilateral is a parallelogram and why? So looking at example 5, what do they have marked on that figure? What does that figure tell us? The marks on that figure, what do they tell us? Caleb, what does it say in example 5? When you look at those marks on example 5, what do you know about that quadrilateral? No. Well, let's look at this then, Caleb. 'Cause I think you're going to be. What is this called in this quadrilateral? What's that called? Right. And what's this one called? All right. And they're intersecting, right? So when they intersect, we've got this segment marked congruent to this segment. So that means this diagonal does what to this diagonal? Mm-hmm. And how about here? Now we know that this diagonal does what to the other diagonal? Bisects it. And that's one of our tests, right? If the diagonals bisect each other, now we know it's a parallelogram. So now we say yes. I can. Because the diagonals bisect each other. So looking at example 6, what do they have marked on that figure? What do they have marked on that quadrilateral? Kamara? All the angles are opposite angles are congruent. Very good. And if opposite angles are congruent, that is one of our tests that we have that it is a parallelogram. So now we can say yes, this is a parallelogram because not just the angles, but the opposite angles. We're going to say both pairs of opposite angles are congruent. Hand sanitizer right down the end. Yeah. Any questions on example 6? All right, example 7. So someone mentioned this concept. Let's look at example 7. They're still asking us to prove, is this quadrilateral parallelogram, and we still have to tell them why. Simon, please pick your head up, buddy. So what do you think? Anaya mentioned this concept at the very beginning. What was one of the things you told me about the diagonals, Anaya? They create two congruent triangles. So I have one pair of sides, opposite sides marked congruent. I have one pair of alternate interior angles congruent. So could I say that this triangle is congruent to this triangle? Tommy? So keep your eyes on, man. Do these triangles, what do we know about this diagonal on these two triangles? We worked with triangles at Tyron? Yeah, it's congruent by the reflexive property, right? So now we know they actually have, these triangles have two sides that are congruent, and they also have the included angle. So it's side, angle, side, side, angle, side are congruent. So we can say, yes, this is a parallelogram because this diagonal creates two congruent triangles in the quadrilateral. And that is how we know it's a parallelogram. And make sure you give the reason you know that they're congruent. You can't just tell me that they're congruent. You have to give me the theorem or postulate or rule or whatever to prove that states that they are congruent by this theorem. You already wrote it, Kamala? Oh, no, you're writing it. And the last example, can we say that quadrilateral is a parallelogram? What do you think? Tyron? So Tyron said we can say yes because one pair of opposite sides are parallel and congruent. But they don't tell us that those sides are parallel, do they? They don't. So we have to say no here. We can't prove that this is a parallelogram because we only know that one pair of sides is congruent. We need either both pairs of opposite sides congruent or this same side would have to be congruent and parallel, right? So no, because we only know that one pair of opposite sides is congruent. We would need to know that either this side is also, this opposite sides are also congruent, or that this same pair of congruent sides are also parallel. That was the new one we learned today. Any questions? Right, if you need me to go back to something, I can.
Example 6.
Example 6, yep. If you're finished with your notes, you can scan and submit and then put your phone. Where should your phone be, John Luke? Oh, it is? What's in your pocket? Oh, okay. Make sure you drop your phone back down in your backpack after you scan and submit it. If you need me to go back to another page, I can. I do want you to be working up until 1 minute until the bell, so do not pack up before 11:15. You have 10 full minutes. Gad, why is that in your ear?
I forgot it was in my bag.
So you're going to write your name here on example 3 and put the time. I think you went yesterday too, didn't you? Okay, good. Does anybody need me to go back any other pages?
Oh, you have the first.
Okay. Okay, I'm going.